Tuuurrrboooooooo. Hey guys, and welcome back to another YouTube tutorial about platforming. So this is the second part video of our platformer template video. It's a three-part video process. This one's going to go over gravity and player movement as well as collision. So we have three kind of things that we're going to be touching on. My name is Chris. I went over the first part of this video, and if you guys buckle up, we can go over this second part together. So without any further ado, we're going to jump into it. This is the same document that we had in the first part of the video. So if you're a little behind, go and check that out, get caught up. We'll be picking up right here on the function contains. So we're going to copy this. We're going to go over into our code and we're going to slap it right into our tile imply. You can put it below draw, above draw, it doesn't matter. I'm going to throw mine above draw right here. So this right here, this function is going to check if a pixel is contained within these tiles. Let's break it down line by line here. We have these first two lines here that are saying tile X and tile Y are going to be equal to their grid X and Y positions multiplied by their tile size. Tile size is 16 bits. That's one of our constants up here. So it's a value that will never change. So tile size 16, so whatever the start X and Y position will be multiplied by 16, and that will be our tile X and tile Y. Now down here we have 4 checks that need to be true in order for function contains to be true, and those are going to be 2 horizontal checks for our X positions and 2 vertical checks for our Y positions. So essentially there will be an X1 and a X2 and a Y1 and a Y2, and this will be important for later functions that come to play here for collision, but essentially we are checking the leftmost corner for our X's, our rightmost corner for our X's, our top left point for our Y's, and our bottom right point for our Y's. So we have you can imagine like a square. We have a top and bottom check for the square and then a left and right check for that square. So if it is inside of that, then it is contained. Let's jump into the next bit here. We have a pretty big slice here to work through. This is going to be just added to the general bottom of the file. So in a in a different recording of this, I made a mistake where I put it in here. You want to put it all the way outside, right down here. So this is going to do a check collision function, and then we're going to actually kind of loop on back to that contains function. So I'll break this down piece by piece as well. So the function check collision is going to, kind of like in game state, it's going to say like player X, player Y, direction tiles. All of these are like values, and then those values are kind of iterated down below. The player X and Y, obvious direction, I'll go over this. So right here, this is really where it begins. We're saying let W equal this and let H equal this. W and H, width and height. And we are setting the width and height to 12. Now the width and height of our sprite, the sprite was made on a 16 by 16 sheet. The sprite itself is not 16 by 16. There's some places that we don't want the 16, like we don't want it to just pick up 16 by 16, but there is places where the sprite is taller or wider than 12. So we are adding some extra padding. So on the left side, we're going to add an extra 2, and on the top, we're going to add a 3. So it ends up being 14 and 15 for his width and height on the top and on the left. So then we jump into that directional check here. So this is what I was talking about with the X1, Y1, X2, Y2. So we have 4 kind of cardinal directions that happen here. We have an up, down, a left, and a right that we're going to be checking. And all of these are different collisions. So we're going to do an upwards collision, a downwards collision, a left collision, and a right collision. We are going to check these separately because they all need to be checked separately. For up and down, you'll notice that the X checks are exactly the same. Don't need to worry about any difference when we're doing X when we do up and down. It's really the Y that's changing. And then the same thing for left and right. If you are checking a left and right collision, what's changing is the X values, not the Y values. So the Y values remain the same for left and right. And what these kind of equations are going to return to us is our x1, our y1, our x2, and our y2. And they are going to be checking essentially if a collision is going to occur. So the way it does that is for an upwards collision, we care about this y value right here. So we're checking above the kiwi or our player for that. For downwards, we are checking below our player, so we're going to add in the height, so we can check right below. For left, a negative value is how we move our player to the left, so we are going to check a little bit in front of the player, and a positive value is how we would check the right, so we're going to check a little bit to the right of the player. So those are our 4 directional checks that are happening. And then down here we have a another, like we have a for loop that is basically checking x1 and y1, or this means or right here, or it's going to check x2 and y2. And if it returns true, essentially what we're trying to do is check if this contains ends up being true. So if any of these, if x1 and y1 ends up being true, or x2 and y2 ends up being true, this function, this check collision function, will return true. And it's going to check all of that separately for left, right, down, and up. So jump on to the next bit of portion here. All of these kind of collision codes like work kind of in tandem with one another to determine if there's going to be a collision above, below, left or right, and then there'll be a little bit more that goes into it. But now we have some more constants. So in the first video, we only set one constant. That constant was tile size. Now we have gravity, player move speed max, player acceleration, player deceleration, and player jump force. So all of these are new constants, and they're actually going to play into our movement code. And our movement code is going to be a function inside of the player imply. So this next bit of code right here is adjusting our player imply. So we're going to go into our player imply, which is really just function new and function draw right now. So what I'm going to do to give us more in our player imply here is I'm going to get rid of the one that I have here and just paste in the new one. And so we had function new and function draw. So now we have function handle input, function check collision, and we should have one more function update position. And then there is going to be a new draw function, which I'm just going to update right now because it's rather simple and small. And all it does here is it's going to basically say when our kiwi is moving, we are going to make him kiwi walk, and when he is doing what he was doing before, he's going to kiwi idle. So, and all of this is based off of if the speed value does not equal 0. So if it does not equal 0 for x, he's going to be kiwi walking. If it does equal 0, he's going to be kiwi idle. So that's all that bit is. Then there's a little bit of camera movement code here. I'll do that at the kind of end here, but let's jump into this, that player imply that we're changing. So there is those 3 functions that we're going to go over. The first one being function handle input. So function handle input is, let's break it down again line by line here. We have let GP equal gamepad. So all this means right here is we're abbreviating. So gamepad 0, the first gamepad, is now going to equal GP. So we're going to say if gamepad dot up dot pressed happens. So basically if the arrow key is pressed or the space bar is pressed while the character is landed, so we have if the player clicks up and there is landed, it's going to do this thing, or if the player clicks space and is landed, then it's going to do this thing, is basically what that means. So and means and. It's like two ampersand signs means and then two of these means or. So basically this is landed is tacked on to the just pressed space or the just pressed up. So what we're going to do here is we're going to negative player jump force, and then we're going to set is landed to false. So basically what this means is we're just moving him up, and the is landed is not going to be true anymore. He's going to be in the air, so he can't be is landed, so it'll be false. Now we're going to do left and right movement very similarly to how we did upwards movement, except there's no is landed check. We're just doing left or right instead of space or up. So now we have the X speed instead of the Y speed being manipulated, and these right here are the constants. So player jump force, player acceleration. This would be no different if instead of doing player acceleration, I just added in the manual value, so 1 for player acceleration. So I could put 1 there instead and it wouldn't change anything, but I've already set a constant, so we're just going to do that. So left press, so if you press left, it's going to subtract the player acceleration value. If you press right, going to the right, it's going to add that player acceleration. So in order to move left, we need to subtract. In order to move right, we need to add. And then we have another bool. So instead of is landed, we have is facing left. This is going to affect how that sprite gets drawn. So we have is facing left when we're moving left to be true, and is facing left to be false when we're moving right. And then we have kind of another portion of this. So we have an if and an else if. So if left is pressed or right is pressed, it's doing this. But then if none of that happens, it's going to decelerate, is what this portion of the code is. And then the two if and else if statements in here are decelerating him if he was moving left or right. So if the x speed is greater than 0, so if the x speed is greater than 0, he's moving right because that's a positive value. Positive values move him to the right, so we need to subtract to get him to stop. And then if it was less than 0, it would be a negative value, and if that's the case, we need to add deceleration to stop him. So if he's moving left, what we need to do is add a force to the right to get him to stop. And then we have some clamping right here. So basically we're saying that speeds cannot go over a certain value. So when you have like code and you're adding and subtracting values, if you don't specify stuff, those values can add or subtract infinitely. So when we clamp something, we're setting the maximum that it's allowed to do. So we have the negative player move speed max and the positive player move speed max. It can't exceed those values. And then we're doing the same thing for Y. What we're doing is we're clamping it to the negative jump force, because when we add a negative value, the player moves up, and then maximum gravity is him moving down, which maximum gravity is 15. The handle input function just handles inputs, so left, right, up, and down, and then kind of deals with deceleration, like getting him to stop, and then sets some maximums that can't be exceeded. So function check collision tilemap. So what this is going to do is it is going to check collisions in those directions that we set. So we have the collision down, the collision up, the collision right, and the collision left. So we are going to check all of these collisions, and basically we are going to say that if these collisions did happen, like if the value was returned true, if this collision is happening, if an upwards collision is happening for this one, then we need to do something to, stop him from going through that wall or going through a platform or going out the bottom of the screen. So basically, if it's a downwards collision, we want his Y speed to bottom out, like we want it to hit 0. And then we want is landed to be true, because if he collides with something going down, he's landing. Other than that, if he doesn't collide with anything, then is landed is not going to be true. It's going to be false. Same thing for up. If he goes up, then we are going to, because we have gravity working with us, we're not going to set that Y value to 0. Instead, we're going to, because a negative force takes you up, we're going to add 1. So if he's going up, not only do you have gravity working against you, so we're just going to add 1, and that should stop him from flying through whatever platform. For left and right, we do the same thing because we have deceleration working with us, so it's much like gravity. So if he is moving to the left or to the right, we are going to add the opposite value. So if there's a collision detected on the right, we're going to subtract, because that'll move him kind of like toward the left. It doesn't move him to the left, but it takes away from that right speed. It helps him stop so he doesn't go through your platform. Same thing for the left, just opposite. And then we have function update position. And this is the simplest function. All it's doing is saying that the player's X and Y coordinate value that we set are going to be basically updated by the player's speed X and speed Y. This is important for like a few different reasons. If you are trying to flip your sprite around based off of stuff, it's nice to have, because this essentially is doing the same thing as this. It would be no different if instead of speed X and speed Y, you just had X and Y everywhere. The reason why you want 2 separate like values changing is because if you tried to do, for example, in the function draw right here, if we're trying to do Kiwi walk, you might run into issues where his X coordinate and Y coordinate becomes negative, but his speed X and Y are actually like positive. So manipulating the way he's walking left or right is not always going to be true for the X and Y coordinate, but for speed X and speed Y, that would be true. So that's why it's important to have like different values for that. But function update position is really simple. Function check collision Tilemap is just checking those collisions in different directions, and then handle input is just handling all the input for the speed. And then there was one other thing I wanted to go over. It was this enumeration. I kind of skipped over it. This was back in the function check collision that we added into the very bottom. That function check collision has something in it called an enumeration. An enumeration is much like a struct, but instead it has a instead of like data inside of it, it has a type, which is direction, and then has variants for that direction. So the variants for that direction are up, down, left, and right, and that's where in all these different functions we have the up, down, left, and right. The Turbo doesn't just know this innately, so it's important to specify that we actually set that with an enumeration. So I didn't explain that earlier, so I wanted to at least go over it. And then we've pretty much come to a close here on what we needed to talk about. We just have to update our go loop and then add in our camera tracking. So let's update the go loop first. It's really simple. We have all of these functions and whatnot outside of the go loop, and our previous go loop was rather small. So you'll notice here player draw and state save is going to basically get larger. There's going to be 4 different things added in. So here's player draw and state save. So we added in update position, check collision Tilemap, and handle input. There's one more that we are going to add in, and it's the camera one. So we are going to go to the very bottom of the librs file, so down all the way down here, and we're going to add in the function center camera. So basically, what needs to happen is, because we add in that function, we need to add in the function to the go loop. So this go loop is identical to the previous one. We just copy and pasted, except there is another function that needs to be added into it, which I'm just going to add in manually, and we'll put it right above our draw function, just like it is right here. And then I will go over that code. So that code that centers the player, or centers the camera on the player. So basically what we're saying is that this is a function called center camera. So we have an X and a Y value here, and we're going to say that the canvas width is equal to the canvas size, and the canvas height is equal to the canvas size as an F32 in these values. And then what we're going to do is, you can see right here, it says subtract half the width of the canvas and then add half the size of the player to the center of the camera. So then we're using this to set the camera. So the X and the Y coordinate equals your X minus your canvas width, which is up here, divided by 2 plus 8. The kiwi's size is 16, so we're adding 8, that's half. So right here, add half the size of the player. So half the size of the player is 8. So we're doing the same thing to the Y, except we're using canvas height instead of width. So height divided by 2 plus 8 is our Y. X is canvas width divided by 2 plus 8. And we're setting the camera at this position. So now, after all this is said and done, if I didn't completely bork this in some way, shape, or form, I'm going to save it. We're going to take a look at our kiwi over here. It looks like gravity kicked in. So now I can walk and move around. You can see the kiwi changes his animation. So here's his idle, bounces up and down. Here's his walking, little feeties move. And then if I click up on the D-pad, it goes up. If I click space, he goes up, and then I should be able to hop on these platforms. So I can hop and land on the platforms, just like in any platformer game. Now you might notice there's an issue. I can't actually jump up and get on that platform, and I can't actually jump up and get on these walls. So in our next video, we're going to be going over polish, where we're going to talk about a few different things and kind of make this into a little bit of a better game. You have a very bare bones product right here with just the movement and the collision. There's a few quality of life improvements or polish that we can add, and I'll go over that in the next video. But thank you guys for watching. This has been an official Turbo YouTube tutorial channel. This is the second part in our 3-part series for platforming. So stay tuned. My name is Chris. Follow us on our Discord. It's a great way to get active with us. Subscribe to our YouTube channel. Leave a comment, like the video. All of that helps us a lot. We're trying to make Turbo into something that is going to be really great for anyone who is getting into game development, doesn't know where to start, and wants to get involved and make a game fast. Take care, guys. Have a great rest of your day.